Let us see variance. What is variance? So variance in a statistical measure is variance is a statistical measure of how large of a spread there is within a data set. It measures how far each number in the data set is from the mean. Okay? And variance is represented by sigma square and is derived with the formula summation of x minus mu square I is equal to 1 to the n. The mean of 6 and 4 will be 5. Let us discuss variance in detail. Similarly, the mean of 1 and 9 will also be 5. But the variance in case of 4 and 6 will be 6 minus 5 square plus 4 minus 5 square by 2, that is 1 square plus minus 1 square, that is 2 by 2 is equal to 1. So in this case 4 and 6, our variance is just 1. Why? We have a mean of 5 and 6 is 1 greater than 5 and 4 is 1 smaller than 5. But in the case of 1 and 9, we still have a mean of 4. But here the variance calculation will be like this: 1 minus 5 square plus 9 minus 5 square minus 4 square plus 4 square. This will come to 32, and the sigma square, that is variance, will come to 16. Therefore, the variance in case of 1 and 9 is more than that of 4 and 1. Let us see the variance as a graphical representation. See, we have two values, 4 and 6, and then we have a mean of 5. And then we have 1 and 9, and again we have a mean of 5. But here in this data, see, the difference between the observation and mean is just 1. But in case of this, the difference between observation and mean is of 4. Okay, so we can say that this collection has a less variance than this collection. Now, standard deviation. In statistics, standard deviation is a measure of amount of variation of value about its mean. So this represents how much the value or the observations deviate from the mean. A low standard deviation indicates that the value tend to be close to the mean, while a high standard deviation means that the values are spread apart from the mean. And standard deviation is a square root of variance. So see here, sigma square represented by this formula is our standard deviation, and when we remove the square from sigma, we put the formula under a square root, and that is our standard deviation. Let's see how we can interpret a standard deviation. Suppose this is our mean, and this mean is suppose 100, and this distance from here to here is 1 sigma, that is 1 standard deviation, and this from here to here is also 1 standard deviation, but this is in the negative and this is in the positive, and this central line is our mean. And suppose our mean is 100. So if we move 1 standard deviation to the right, we are sure to find this value to be 110. Why? Because we assumed our standard deviation to be 10. But similarly, if we move 1 standard deviation to the left and this is in negative, so this value is to be 90. This is 2 standard deviation here, If our mean is 100, this value will be 80. Similarly, this value will be 70. So this is the meaning of standard deviation. Quartiles and interquartile range. In statistics, quartiles are the value that divide the data points into 4 equal parts, effectively splitting the data into 4 quarters. Quarter 1 will contain all the data points between the minimum value and the 25% of the data points. Then we have quarter 2 consisting of all the values between 25 and 50% of data set. Then we have quarter 3 that will consist the data points between 50 and 75, and then we have quarter 4 which will consist of all the data points between 75% and the max data point. Interquartile range. Okay. The interquartile range in statistics is a measure of the spread of middle 50% of the data point, and it is calculated by finding the difference between Q3 and Q1. IQR is represented by a formula of Q3 minus Q1. IQR is also used in the detection of outliers. Lower band, which is represented by quartile 1 minus 1.5 into IQR, and upper band that is represented by quartile 3 plus 1.5 into IQR. Any data point falling beyond these bands can be considered as outliers and can be treated accordingly. So this was all that we were going to discuss in this video. Thanks for watching. Please like, share and subscribe the channel. Let us go and calculate our standard deviation. So the formula is STD, and we want the standard deviation for population, and the standard deviation for population is 487.56. We can drag it if we want for quantity as well. Now let us go and calculate the quartiles for our sale. So the formula is quartile inclusive and the next value is quartile. So we want the first quartile, so for that we will write 1 and then press enter. This is the first quartile, and we want the third quartile so that we can calculate the interquartile range and then check if our data has any outliers or not. And this time we want the third quartile, so we will type 3. Okay, and IQR, let us remove some decimal places. Our IQR will be is equal to this number minus this number. This is our IQR. So now we will calculate our lower band and upper band, LB. So lower band will be Q1 minus is equal to Q1 minus 1.5 times IQR, and upper band will be Q3 is equal to Q3 minus 1.5 times IQR so any number smaller than these two. This will not be a minus, this will be a plus, so we will have to change the formula. Here we will have to add. Okay. Okay, so we got our quartiles, then interquartile range, and then the lower band and upper band, and with this we can use the formula if, with, or to determine if we have got outliers in our data set or not. Any value that will be smaller than this and greater than this will be considered a outlier. And one more thing, one more way to detect outlier in our data set is to insert a chart, and the chart will be box plot, box and whisker. Click on OK and see our data has got quite a lot of outliers. So all these data are outliers. We have got quite a lot of outliers, and the data within this is our IQR. So this is how we calculate IQR, upper band and lower band, and on the basis of upper band and lower band we decide if our data has got outliers or not. Thanks for watching. Please like, share and subscribe the channel.